number 2 on physics of motion with acceleration and initial velocity. In a previous video, I showed you how we come up with the concept of and how we come up with the equation for the position of an object based on a reference point, that is how far something is from something, in a situation where there is both an initial velocity and there is acceleration. So there is acceleration present, there is an initial velocity present, and so where does the object end up? Where does the object end up? So that equation we came up with, we really only need 5 equations for all of physics. One is, the 2 that we're going to use most often, the 2 equations we're going to use most often is final velocity equals initial velocity plus AT, and the other one is final distance is initial distance plus initial velocity times time plus 1/2 the rate of acceleration t squared. Those 2 equations are going to cover the vast majority of physics questions in Newtonian or non-relativistic motion. So these are the 2 equations. The other 3 random occasional equations you're going to need. An average velocity, which is the initial velocity plus the final velocity divided by 2. And if you were for some reason given, something is this far from the flagpole and it moves this far, how far is it from the flagpole? You don't really need to memorize that equation because it's just basic common sense. If I'm 5 meters from the flagpole and I move 10 more meters, I'm going to add those together. 15. Or if I'm going 10 miles per hour and my velocity increases by 10 miles per hour, now I'm going 20. So there's that. So you don't really need to memorize those equations. These 2, however, you're going to use these over and over again. So in this video, we're going to do an example problem where we have an object in motion and we are accelerating it. Step 1 in solving any equation is write down what's given. So we're going to produce some variables, and we're going to say the initial velocity is 10 meters per second. We're going to say the rate of acceleration is 3 meters per second per second. We're going to throw in time. We'll say that this thing takes place over a period of 4 seconds. And just to have all of our variables represented, we're going to say that the object is initially, we'll say 15 meters from the reference point. This becomes one of the hardest parts for beginning physics students, is identifying where all these numbers go. And it's possible to look at the units on the numbers given and know acceleration is always going to be a velocity over a time. Time is going to be time, hours, minutes, seconds. Distance is going to be distance. Velocity is going to be a distance divided by a time. So just kind of using the units, you can figure out where they go in the equation. Well, in this case, it's very simple. We've written down what's given. The relevant equation, the question is, what is the final distance? What is the final position? What is the final distance? So looking at our 2 equations, the velocity equation doesn't have distance in it. We cannot use this equation to find distance. And here's the I don't know what that is. What is that? That's my Sharpie diving over the Elmo. I don't know. Here's the trick. If you don't have final velocity, use this equation. If you do have final velocity, use this equation. If you don't have distance, use this equation. If you do have distance, use this equation. This is the only equation with distance. This is the only equation with final velocity. Final velocity, distance. So that's how you know which equation to use. Our question was, what's the final distance given these variables up here? So d sub f equals d sub I plus VIT plus 1/2 AT squared. And it was at this point last year that I acquired all the colored Sharpies so that I can identify the things more easily. Where's my VI? Here's a VI, here's a VI, and there's the number that's going to go in VI. Here's the thing. T appears in two places. And acceleration is there. Half is not a half is constant. So I'm going to plug the numbers in now and simple plug in and solve. So DI is 15 meters plus VI is 10 meters per second times 4 plus 1/2, 3 meters per second squared. I'm out of room, times 4 seconds. The seconds are going to cancel, and it's 4 seconds squared. The seconds are going to cancel. So, because this is such a disaster, I'm going to go ahead and do this one out. 1/2, 4 squared is 16. 16 times 1/2 is 8. 8 times 3 is 24. The meters are not canceled. The seconds squares and cancels out, so this ends up being 24 meters. Here, I have 10 times 4 is 40. The seconds are going to cancel, and it's going to leave me with meters. 10 times 4 is 40 meters. And here I have 15 meters, and that is equal to our final distance. The handwriting. All right, anyway, 55 plus 24. So 15 plus 40 is 55. 55 plus 24 is 79. Meters, meters, meters. That's a good thing. D sub F. There you go. Example problem solved. Again, write down what's given, write down the relevant formula, plug in, and solve. So there you have an example of find that final distance where all of the other stuff is given. Finding any of the other pieces is just a matter of algebra, and I'll do another video later on where we solve for A or we solve for T, which are the most complicated in the algebra side of things. I lost my train of thought. What was I saying? I think I was trying to close this video out. So let's do that. Thank you for watching. Like button, comments, share, subscribe. See you in the next video.